Hello, and welcome to Module 1, Lesson 3, which is remote sensing. So this is basically just talking about all the different ways that we can use satellites or use things and see things when we're not there. That's what remote sensing is. So looking at this image, you can see that it's an aerial view. And so it's showing a river system. So you can see it's a delta going into a large body of water or the ocean. And so what's kind of cool about this is it's a satellite view. And so we don't have to be here in order to map this out. And so that would be remote sensing. So this could be a really um, remote area where we can't get to, or maybe we can just see it better to map it. And so remote sensing is when you're actually looking at something without being there, or mapping it or exploring it. All right, so satellite is just the term satellite. Sometimes people get confused. They think it's just man-made, like the satellites that orbit the Earth. And so what it is, though, is it could be anything that orbits another body. So technically, the moon is a satellite. The moon is a satellite of the Earth, whereas there's Jupiter, it has 80 something moons. And so those are all satellites of Jupiter. So a satellite is just something that orbits something else, human made object or natural object. All right, and then a Landsat satellite, a specific kind of satellite, it's basically measuring wavelengths of visible light. And so we can use this to study air pollution, air quality, sometimes the purple monitor that measures smoke and stuff in the air that we're familiar with from having so many fires in our area is Landsat. So all of those things, it could be looking at movements of air, looking at movements of pollution, all kinds of things. So those are a specific type of satellite that does a specific thing. All right, and then Jason satellites, you can see in the picture down here that Jason satellites are basically bouncing waves off of the surface of the Earth. So Jason satellites are specific just to measuring the ocean. So what this shows is that we can see from years 1993 to 2008, and then you can see the amount of surface rise. So you can see that the surface of the ocean is rising, and that's because of melting. So glaciers melting. So we can actually monitor that change and see that oceans are indeed increasing because of melting, and there's more water in the oceans. So that would be a Jason satellite. So we use those, and it can measure within a few millimeters. So it's pretty specific, pretty accurate. We can also use those to measure the ocean bottom and measure the ocean floor. So any of the images that you might see, like on Google Earth, for example, those are from Jason satellites. And so they're measuring the ocean floor and all the features and things that we'll talk about later throughout this year. All right, so sonar. You might be familiar with sonar if you have a fish finder on your boat. Sonar is basically just sending sound waves, and they bounce off the bottom. So in this picture, you can see this boat is sending sound waves. So the yellow would be the sound wave being sent, and then red is it reflecting back. So it's reflecting back, and the amount of time that it travels through the water is the depth. And so you might, if you have a fish finder, if you're familiar with that, it shows where the fish are, and it bounces a sound wave off, and it bounces off the fish and comes back and shows up as a fish. And so same thing for the ocean bottom, same thing for monitoring terrain on the ocean bottom. We can use sonar. A lot of organisms use that. Well, not a lot, but some. So like dolphins, for example, whales use sonar. Echolocation from bats, that's a type of sonar. It's not in the water, but it's a type of sonar in a sense, but it's called echolocation. All right, so like I said, the sound wave is sent from the ship, bounces off the bottom of the ocean floor. That echo, that ping, maybe you've seen movies where in a submarine, they're sending out sonar, and it's coming back, and it's making like a ping sound, like a ping, ping. That would be sonar. And so they're using that to determine where they are because they don't have windows in a submarine. So they use sonar to figure out where they're going. And then we can calculate the depth of the ocean floor, and we can do all kinds of things using that. And we do a variety of things. So the last bullet talks about things that we use sonar for. So fishing, like I mentioned, deep sea drilling, oceanographers use it to map the ocean bottom. Volcanologists, so there are lots of volcanoes on the ocean bottom, so we use that to map those. And then archaeologists, maybe they're looking for the Titanic, or they're looking for other things like that. So that would be a way that they use sonar. And then GPS, you guys are probably all familiar with GPS. On your phones, you have GPS. If you've ever used Google Maps or any kind of mapping system, it uses GPS. If you use Strava, like if you ride your bike and you track your ride or run or anything like that, that uses GPS. And so it's just a navigation system that is communicating with satellites. And I think there's over 30 satellites that are dedicated just to GPS orbiting the Earth. And so it was originally used for the military. So the military developed it to pinpoint with accuracy missiles and things like that. And then now we use it also for our phones. And it's very accurate if you've ever used it with Google Maps or something. It's pretty accurate. It doesn't, military GPS will pinpoint things down to like a millimeter, like a centimeter, like really tiny. But our GPS is good for a few feet. So it might not detect that you're on one side of a classroom to the next, but it will detect that you're in the classroom. And so that's what GPS is. And you can see in this picture here, there's a whole bunch of satellites orbiting, like I said, 30 something satellites orbiting the Earth, and they are all dedicated just to GPS. And that's to help people find things for military use. Airplanes and ships use it. We detect earthquakes, track wildlife, which we'll see in a minute, all kinds of cool things with GPS. And so that's an example of a way technology has helped us. So technology was developed for the military, but now it's used for everyday life as well. And that's a really good example. All right, so GIS is the last type of map, and a GIS map is using a database, and it's usually layering maps. So they take like a topographic map, and then they might take a satellite image, and then they might track an animal on top of it, which we'll see in the video in a minute. So that would be a GIS map. So it's just a bunch of layers of maps on top of each other. And I showed you one in the classroom. So you guys saw in the classroom a geological map. So the geological map was the rock ages layered on top of a topographic map. And then it was also layered on top of just, well, I guess it was those two, but it was topographic map and the ages of the rock. And so that was an example of a GIS map, which is also a geological map. So on this video that I'm going to play for you, it's kind of neat. They used a GIS map. So they used a regular map and then they tracked these deer, and they realized how far they actually travel, which is pretty amazing that these deer travel this far within a year. They migrate back and forth. And so this was a great example of using GIS. So pretty amazing how far the deer actually traveled. 255 miles was her world record. That's pretty amazing. And that's something that occurs every single year. So it was just kind of neat to see how they tracked the deer with probably a collar. And then they had the GIS map on top of it, 3D. It's just very cool. And so we can use it for a huge variety of things in science. And that's it. So I hope you enjoyed remote sensing, and I will see you next time.